Hello students, today we are going to do a new topic of MSc Mathematics students, that is Lebesgue point and Lebesgue set of a function, and moreover we will do an important theorem related to this. So we first do the definition. Let f be an integrable function on interval AB. Then a point x in AB is said to be Lebesgue point of f if limit h approaching to 0 1 by h integral x to x plus h mod ft minus fx dt integral is 0. If the point x satisfies this condition, then we say that x is Lebesgue point of this function f. And if we collect set of all Lebesgue points of f, then this set is called Lebesgue set of the function. So here are the two definitions. So on the basis of these two definitions, we will do a theorem which states that if f is a Lebesgue point of the function f, then this new function capital Fx, which is function of x and is defined as a to x integral of ft dt, this integral exists because f is integrable function, plus fa, a new function of x, then this is also differentiable at x, and one more condition is true, that its derivative f dash x is equal to small fx. So let's start with the proof of this theorem. Now to prove a function to be differentiable, we have to prove that the limit fx plus h minus fx upon h limit exists. We want to basically prove this thing, that this limit exists. So we will consider, and we want to prove that this limit is equal to fx. So to start with, we will start with this term minus fx. Now what is the value of fx plus h? Now as we know that fx is a to x, so fx plus h will be a to x plus h ft dt minus a to x ft dt. H is divided in both the terms and minus is fx. So in this integral, the first is from a to x plus h and the second is from a to x. So if we subtract the integral from a to a plus x with this integral from a to x, we will be left with the integral from, see, this is x to x plus h ft dt. Now I can write this fx as 1 by h into h fx. I think no problem in that. So I'll take 1 by h common, and inside I can write this fx as x to x plus h fx dt. With respect to t, this x will be constant. Now club the terms. What we'll get? 1 by h integral x to x plus h, because the limits are same, modulus ft minus fx dt. So as we all know, the modulus of an integral is less than equal to integral of the modulus. So this is x to x plus h mod inside ft minus fx dt, and as we are given that x is Lebesgue point of f, it means this limit is 0. So we have reached at this limit, this term, and as h approaches to 0 on both sides, so we see that this term approaches to 0. Why? Because x is Lebesgue point, right? So if this thing approaches to 0, it means this thing approaches to 0. So this means that limit h approaching to 0, fx plus h minus fx upon h is equal to fx. So what is this? This thing is derivative of capital F at point x. It means this thing is equal to small fx. So that means our f, capital F, given in the statement is differentiable at x and its derivative is equal to small fx. So hence we have proved it. Thank you.